The dummy variables can be applied to various problems, and one of them is seasonal analysis. As you will see in the future, many economic time series based on monthly and quarterly data exhibit seasonal patterns. For example, demand for money by households at holiday times, right? So usually we demand more money during Christmas times, probably Easter times. Demand for ice cream and soft drinks during summer, right? Usually we want more cold drinks and ice cream during summer than in winter. Demand for air travel, again, people prefer to travel in summer more than in other seasons. So this is where the seasonal patterns come from our human behavior. And often it is very, very much desirable to remove the seasonal component from time series so that one can concentrate on other components, right? So that our results are not affected by seasonal components. So we know that there is no seasonal component and our variable behaves the way it behaves, not because of the season in which the variable is, but because of other factors, so other variables. And this removal of the seasonal component is known as deseasonalization or seasonal adjustment, and the time series without the seasonal component is called the deseasonalized or seasonally adjusted time series. Let's have a look at this example. So suppose we've got some data for a number of years on the sale of refrigerators, and we would like to remove the seasonal component from the sales of refrigerators. In other words, what we would like to do is we would like to remove the dependence of sales on a season. So we would like to remove the seasonal component. So in order to do that, in the first step, we need to run the following regression. So we need to regress the sales of refrigerators on dummy variables where they represent the seasons, and they take the value of 1 in the relevant quarter and 0 otherwise. So D2 takes the value of 1 in the second quarter and 0 otherwise. D3 takes the value of 1 in the third quarter and 0 otherwise. And D4 takes the value of 1 for the fourth quarter and 0 otherwise. So in this case, the benchmark category is the first quarter. So after we've run this regression, after we've obtained some results, we move to the second step, and what we need to do is we need to find the estimated values of y. We can do this using the software, right? So we just take the value of the coefficients and we estimate them, and we get the estimated values of the dependent variable. After we've done this, we take the estimated values and we subtract them from the actual values of y, from the given values of y. So in a sense, what we get is the so-called residuals, which represent the remaining components of the refrigerator time series, namely the trend, cycle, and random components. So by subtracting the estimated values from the actual values, we get the so-called deseasonalized time series. So once again, to get the deseasonalized time series, we need to first of all regress the dependent variable on the dummy variables representing the quarters of the year. Like in this case, in the example of sales of refrigerators, we kind of regress the sales of refrigerators on the second, on the third, and on the fourth quarter, removing the first quarter and making it the benchmark category consequently. After this, after we've obtained some estimates of alpha 1, alpha 2, alpha 3, alpha 4, we get the estimated values of y. And after this, we take those estimated values and we subtract them from the actual values of y, and this is how we get the seasonalized time series.